Okay, let's get started on our first lesson. So we're going to talk about quadratic functions. These are those parabolas I was showing you on the first page. It's our first type of curve that actually changes direction and things like that. In Algebra 1, you studied a bunch of linear functions. Lesson 1.1. So our objective, you don't have to write these down unless you want to. I mean, students will be able to graph these things, and you want to be able to explain the process to another. What I want you to be able to do is know it well enough so that you could explain it to your friend if they're absent. Usually if you know it well enough, you can explain it to someone else. Alright, so what we're going to want to know when we look at this quadratic equation, what do these little things do in the numbers that are out in front? Like, here's a typical equation. We might have like y is equal to, say, 2x squared. And then we might have minus 3x. And then we might have plus 5. Well, when we have our graph, it's going to be some parabola. I'll just show you. The graph might be over here, you see? Well, so what we're going to want to do is, what does that number do? What does this number do? And what does this number do? They all have a little role in moving this graph around. And sometimes the graph becomes flatter like this, like that. Sometimes the graph becomes really steep, like that. So all these little numbers have a little role. And so that's part of what we're going to be doing in this first lesson, is learning what those numbers do. Okay, so a few definitions. What is a quadratic equation? Well, those parabolas, they always look like this. Okay? Now, you don't have to write it down because it's on your study guide already, right? It's on your study guide? Okay, so notice when we were dealing with lines, we had like y is equal to mx plus b. All of those guys look like a straight line. Yeah? Oh, thank you. I'll use this cool color here. Is that cool? No? Okay, let's try this one. That's not bad. Okay, so usually yellow is hideous, but okay, so lines are always straight, like this, right? And they always look like this. You see? And what's the exponent? The exponent is always like a 1. And the parabolas, they have an exponent of 2. You see? You always have this term in here to make it a parabola. Sometimes we call it quadratics. Quadratics, parabolas, same idea. Okay, a parabola is the graph of a quadratic function. And anyhow, that square there causes the graph to have a bend in it. It has a bend, one bend. And if this were a cube, then it would have 2 bends in it. Does that sort of make sense? So each time this number goes up, it causes basically a bend in the curve. Well, not always, but usually it causes a bend. Okay, so we're going to find out about these guys. Now, notice a does not equal 0. You can't let a equal to 0, because if a is equal to 0, this term would disappear. And if that term disappears, it's no longer a parabola, it's a line. You see? And it would be a straight line instead, like that. Okay, so that term has to be in the equation to make it a... Remember, that square there makes it curve. It bends. It has a bend. Okay, so I'm going to erase this jump. You guys understand this so far? And so what we say is that the graph of a quadratic function is a parabola. People will say parabola. Ebola, parable. No, we say it parabola. Parabola. Okay, don't worry. I'm not going to grade you on how you pronounce words. Okay, so here's the parent function. Now, what we'll do when we start out graphing is we'll graph the parent function, and then we'll graph another function and compare it to the parent function. So the parent function is basically the most basic of the parabolas. Does that make sense? It's like all the other ones look just like it, but they might be more flat, might be steeper, they might have moved somewhere, okay? But the parent function is the one that's like all of them. It's the most basic one. And so there's certain things we should know about all parabolas, okay? And some of the things you'll notice is that they have a vertex. The lowest point or the highest point is called the vertex. Okay, so, whoops, let me get out my pen. And the vertex for the parent function is right here in the middle, and it's at the origin, 0, 0. So this is for the parent function. Okay. Now, sometimes parabolas will have a highest point, and it's called a maximum. Okay, but it's still called the vertex. All right. Now, this line that's going down the middle is called an axis of symmetry. Okay. You'll see that here. Axis of symmetry. So all parabolas have an axis of symmetry. What's nice about this fact is that when you're graphing, if you know this point right here, you see that point is 2 units to the right, right? You see that? Oh, now my yellow is hideous. So I'll use my cool color, blue. Blue. You see that's 2 units? Well, because that's an axis of symmetry, there has to be another point on the opposite side that's 2 units. You see? So there's this idea here. That's how the axis of symmetry is handy. If you know the axis of symmetry, you know there's always an equal distance on both sides. Does this sort of make sense? So like this one, that's 1 unit. So there has to be a mirror image spot on the other side of the axis of symmetry. So on parabolas, these are certain things we want to know. We want to know where the vertex is. We want to know the equation of that axis of symmetry. And then what we want to do is plot a couple points. And all we really need to do is plot one side, because we can get the other side by using the mirror image idea. Does that sort of make sense? So those are some basics about parabolas. Okay, so what we're going to do with your first couple problems, and we'll do a few on your study guide as well here in just a few minutes. I'm going to show you how to graph both of these. Okay, so what on a single graph, we're going to graph the parent function. Whoops. We're going to graph the parent function. Oh, I thought I grabbed my eraser. And then we'll graph this one. Okay? We'll graph them both. Okay? Now, sometimes to graph them, let me go back here. Well, sometimes to graph them, you just make up a little table of values. Like you put in these x values. Like if you put this x value in right here, okay, what do you get for the y value? Like if you put, now be careful here, if you put -2 in here, and you can't see it? Oh, hang on. Let me choose a different color. How about white? Okay. If you put in -2 here, you guys always do that. If you can't see it, tell me. If you put -2 in there and you square that, what happens? You see? You get +4, right? Because a -2 times a -2 is equal to +4. So there are a lot of people that would have put a negative here and they would have made a mistake. You see? The x here is being squared. Okay, so well, then what you do is you put this point in over here for x, like that, you see? And so then you do -1 squared. And some of you guys could do this in your head, right? -1 times -1 is +1, right? So there's a 1 here. And then we're going to put 0 in. Well, 0 squared is just 0, right? So we put 0 here. And we put 1 squared, we get 1. And then we get 2 squared and we get 4. Alright, so now what we want to do is start plotting this thing. So the x coordinate, when I'm at -2, there's -1, -2. The y coordinate is 4. So 1, 2, 3, 4. There's a spot right there, right?
So for when we're doing the breaking down of the parent, we have to use -2 on the spot of 2?
Yeah, usually a good range of values is sometimes even to -3 to +3. You can sometimes do 6. On this example, I'm just doing those 5 values only. Okay, so let's continue finding this one. At -1, we're at +1. And at 0, we are right here. And at 1, we're right here. And at 2, we're back up to 4. Okay, so now I want you to make your graphs kind of pretty. Nice and pretty. Okay, so here's our parent graph. It kind of goes like this. And realize that parabolas are a little bit curvy. They're not pointy. Okay, so there should be some sort of roundness to them, you know, kind of going like that. All right, now hopefully you have the parent. Is the parent function on your study guide?
Don't look at I don't know this one.
Or let me look at your study guide real quick.
That's the other one.
Okay, so they showed you a different one. That's fine. We'll get to those eventually. Okay, so on most of your problems in the beginning, on the beginning of your assignment, you graph both of these. Okay, you're going to graph the parent function first. Okay, now after you do the parent function 2 or 3 times, you're going to know that one automatically, and you just put it on your graph. Okay, make sense? It's going to be the same graph every time. That's the parent one. This one is an offspring. Think of it as a daughter or a son or something, cousin. I don't know. This one's different because there's a 2 in front. So what we want to find out, we want to compare this one with this one and find out what that 2 does. What does that 2, how does that change the graph of the parent function? It doubles it. That is, yeah, that definitely doubles it, right? Because you're multiplying by 2, right? So what we're going to do is go through these values again and just, now if you're smart, you can just double these, right? Because, well, I'll do it in slow motion this time. Okay, you guys will work faster because you guys are all smart, but you guys had summer vacation. Your brain is kind of slow still, maybe. Maybe. Some of you guys have fast brains, faster than mine even. But the point is, let's erase these values. And we're going to go through these values again. And now I'm going to use a red. I'm going to put these numbers in here now. You see? I'm going to put them all in here. So what I'd have for that first one, I'd have 2 times -2, and then I square it. Okay, like that? Oh, you guys can't see that. How come no one said anything? Okay, so how about if I try this cool green? Okay, I have 2. Is that cool? No, you can't see it? You can? Oh, here's what I should do. Now you can see it, right? Okay, so there's -2. Now, we saw before that if you square -2, you end up getting 4, right? You get 4. But now we're multiplying by a +2, which makes that one 8. Okay? If you plug in the -1 up here, okay, well then we get 2 times -1. And we saw what happens when you square -1, right? You end up getting +1. So you get +1 times 2, and you get 2 right here. And then we saw what happens if you put in a 0. That one should be obvious, right? 0 squared is 0. 2 times 0 is 0. So that one's 0, right? And if you put in 1, now how many of you guys realize there's a quick way to do this? This one is always the same as that one, right? And this is the same as that one, right? So this is 2 also, and that one's going to be 8. Okay? No. Look, the negative number goes in for x, and it's squared. So when you square a negative, it makes a positive. Alright, so now what's the graph of this one look like? Well, when we're at -2, we're clear up at +8. So 1, 2, 3, 4, 5, 6, 7, 8 would be right here. So there's our first little spot right up there. You guys see that? Yeah, looks pretty cool. Okay, well at -1 we're at +2. So that one's right here. And then when we're at 0 we're at the same spot. And we're at +1 we're at 2. And we're at 2 we're at 8. So we're clear up here. Okay? So you might notice if I connect the dots here, and this is a little bit harder for me to do on this little pad here. What did you notice happened? It got steeper, right? So we discovered in a sense what the 2 causes. If there's a 2 out in front there, it causes the graph to get steeper. That makes sense? And what we call that is it's a compression. The graph starts out like this and then it's compressed. Like when you compress something, you compress it this way. We call it a compression. When you start here and you go flatter, it's called a stretch. Does that make sense? Now, in this way, you can call it a stretch also because it's almost like you're stretching it up the vertical axis. The vertical is going up and down, right? And so it's almost like you've taken this and stretched it up this way, and so now it's, you guys seen rubber bands, right? I'm just thinking in terms of a rubber band. I don't know if I have a good rubber band, but anyhow, it's like we're stretching it upwards. Okay, so we might describe this, we might say that this 2 causes a vertical stretch. Vertical stretch. Okay? Alright, so it makes it more narrow, whatever. Okay? So you get the idea? So on several of these problems, you're going to be doing this sort of thing where you graph the parent function and you graph this new function. Alright. What I want you to do now, go ahead and do number 1 on your exercise, on your study guide. You'll see your study guide. Let me show you. And what I want you to do is you have your graph paper too, right? So let me show you something real quick. I'm going to grab the study guide real quick. What I want you to do, and this is all I want you to do because I don't want to cover a new problem yet. I'll just confuse you, I think. You see this problem right here? It's just like the one we just did, right? Okay, so what I want you to do is on your paper, you can graph. Here's what I would recommend. Whoops, let me go back to my paper. Study guide right here. What I want you to do, you have your graph paper, right? Where's my pen? Okay. Oh shoot, I can't. Oh shoot. Okay, I have to be clever now. Alright, let's see if I can be smart enough to do this. Okay, wait. I want more tools. Where's my camera at? Oh, there's my capture one. I want to do a partial. I want to capture this guy right here. Oh shoot, I wanted it on a separate page. Alright. Yeah, you gotta do both. Let me show you real quick. Okay, so let me grab my capture tool again. Partial. Okay. Okay, it's sitting right here. Yeah, look at that. Yeah, I'm getting pretty good. Okay, so here's what I want you to do now. What you're going to do is you're going to do x's and you're going to do y's. And then you're going to do a second x and y, right? Okay. Now, the first one, it will take a while to do this, but you'll do the parent function first, okay? The parent. And then you're going to do this one over here, okay? Now the parent function you're using is y is equal to x squared, okay? So let's do -2, -1, 0, 1, and 2, okay? And you'll do the same values for this one, okay? So you're going to do like -2, -1, 0, 1, and 2. And then on your graph paper, okay, you're going to graph them both. Now if you have two colored pens, That makes it really cool, because then you can do one graph in one color and you can do the other graph in a different color. That makes sense? Now if you're clever, like Noel is, the only difference between these two is that you're multiplying by 6. So if you find all these values right here for the parent function, just multiply them by 6 and you'll have all these. Does that make sense? And just be smart, okay? Alright, and then once you get done with that, we'll just stop right there, because I don't want to cover much more, because you'll forget it over the weekend.